Thanks for joining me here at Math Rocks with Mr. Cox. In this video, we're going to be looking at the idea of probability and how it applies to games of chance. In this case, we have spinners. So we have one on the left over here where obviously you're much more likely to land in the 12 zone than the 8 zone. But what would happen if you just play this lots and lots of times? What would it average out to be? Or over here, we have you land in either positive 60 or positive 32, or perhaps you lose $100 if you were playing this spinner game. But once again, what if you played this thousands of times? What would happen on average? And it's going to involve this idea called expected value. So stick around and you'll find out how it all works. Let's get it on! So let's take a look at how expected value, first of all, what is it and how it's calculated. The definition is really nothing more than it's the average. And in this case, it's the average amount you either win or lose when you're playing this spinner over here. And there's actually a formula for it. And what you're going to do is you're going to add up each outcome times the probability of it happening. But let me show you where this formula comes from. So imagine you were going to spin this 4 times. And I'm looking over at the spinner. If I divide this up here, and I divide this into fourths here, I would expect it to land 1 out of those 4 times on the 8. So I would get an 8 once, and then I'd get a 12 3 times. Now, it's not guaranteed, but that's what I would expect to have happen, hence the name expected value. So I would add these all up, and I would divide by 4 to find the average. So if we add these all up, 12 plus 12 plus 12 is 36, plus 8 is 44, and 44 divided by 4 is 11. And then, I could change it up here. What if I spun this 100 times? Well, once again, I'd have to think to myself, well, that's a fourth of that circle. So a fourth of 100 would be 25. So I'd expect 25 eighths. And then the difference would be 75. I'd expect 75 12s. And then whatever that is, I'm going to go ahead and I'm going to divide by 100. So 25 times 8 is 200. And 75 times 12 is 900. And I'm going to go ahead and divide by 100 to find the average. And that would be 1100 divided by 100, which is just 11. So once again, we get an average of 11. And by the way, what's strange about this is you can never actually roll or spin, in this case, an 11. However, that's the average, it appears. So how the formula works, you don't have to necessarily think about how many times you're going to spin it. You just have to think about the probability. So the chance of getting an 8 would be a quarter. So this is how I would do it if I was actually running the formula here. So I'm going to go ahead and do it right over here. I'm going to take the chance of that happening as a quarter. So I'm going to take a quarter times 8. And then the chance of getting a 12 would be 3/4. And that's it. I would figure this out. Well, 1/4 of 8 is 2. And 3/4 of 12 is 9, and I would add those together and I would get 11. So really, that's it. You're just going to be taking the sum of each outcome times its respective probability.
If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to part 2.
Now we're going to go ahead and look at, once again, finding the expected value, but also adding another layer on called, is this a fair game? And by definition, a fair game is only true if the expected value is 0. If it winds up being a negative number or a positive number, it would not be considered a fair game, either for the person playing or the person who's actually setting up the game, in Vegas, that you would be called a dealer. So let's figure out the expected value here. So let's go ahead, and what we're going to need to do right now is we are going to need to figure out each of the probabilities. I know that this is 90 degrees over here. And that's going to be 1/4 of the circle. Unfortunately, I don't really know exactly what the chances of landing in each of these. Now, I know this is 108 degrees. I also know in a circle, there are 360 degrees. So if I want to figure out, I know that's 90 and I know that's 108. If I were to go ahead and subtract 90, and I were to go ahead and subtract 108 degrees, that would actually give me how many degrees this area is over here, which is going to be helpful. So 360 divided by 90 is 270, and minus that would be 162 degrees. So that's how big this area is here. So how we're going to do this is to figure out the chance of that happening is we're going to actually say to ourselves, well, I know that's a quarter. That's a pretty easy one. Let's start with that one over. So I'm going to go a quarter of 32. And then, 162 degrees, how would I figure that out? Well, I know a circle is 360 degrees. So I'm going to make it 162 over 360. That's the probability of landing over here. And if that happens, we get a winning of $60. And then finally over here, we're going to get that chance would be 108 over 360. And then what would happen if we landed in this zone is we'd actually lose $100. So to find out if it's a fair game, once again, we're gonna calculate this. We don't just say, well, 60 plus 32 is 92. That's negative 100. So you're gonna lose an average of $8 because that's what happens if you add these up. Because these zones are all different sizes, the chance of landing in each zone is a little bit different. So that's why we need to do expected value. Then you're going to go ahead and actually do the math on this here. So if you take a quarter of 32 on your calculator, you can just go 1 times 32 and then divide by 4. So 1 times 32 divided by 4 would be 8. On the next one, you would take 162. You can multiply it by 60 and divide by 360. And let's see here what would happen there. You'd actually win on an average $27. That's what this calculation would be. And then finally over here, if you took 108, multiply it by negative 100 and divide by 360, that would be negative 30. And then we add these numbers up. 8 plus 27 is 35, and 35 minus 30 is a positive 5. So this would not be considered a fair game. So this I'm going to write right here, not a fair game. I realize if you're playing this game, that's great because what's happening now is you're winning $5 on average. Now, once again, like before, are you ever actually winning $5? Well, no, you're either winning 60 or winning 32 or subtracting 100. But over the long haul, if you play this thousands and maybe even millions of times, you're going to win on average $5, even though sometimes you're going to be losing 100 and winning 60 or winning 32. So once again, this is not a fair game because the expected value is equal to 0. You could make it a fair game by making someone pay money. And so if you made them actually pay money to play, in this case, you'd want them to pay $5 to play because you're now negative 5 once you pay to play, and you're going to win 5 on average, and together that would be 0. But as is, if you're not paying anything at all, it would not be considered a fair game. All right, that's it. That's expected value in a nutshell, and that's also what's a fair game. Hope you enjoyed the video, and hope you come back soon to see more videos. Thank you.